Hi guys, this is organic chemistry and we are looking at types of formulae of different organic compounds and we'll be looking at four carbon compounds. So to begin with, we are looking at alkanes. So a four carbon alkane is called butane. So the general formula of alkanes is R and H, and in terms of the number of elements present in the formula, it would be CnH2n plus 2. So that is the general formula of alkanes. Next, we will look at the molecular formula of butane. Butane contains four carbon atoms. So C4 and H would be 2 times 4, which is 8 plus 2 is 10. C4H10. So that is the molecular formula of butane. Now looking at the empirical formula. The empirical formula is the simplest ratio of the elements in the compound. So C4H10 can be simplified as C2H5. Next, we will look at the condensed structural formula of butane. So we would have a CH3 group, then a CH2, then another CH2, and finally a CH3 group. So this is the condensed structural formula of butane. Now, in order to see the displayed structural formula of butane, every bond present will be seen. So this will have four carbon atoms and every carbon atom will be bonded to different number of hydrogen based on the number of bonds already present. So the terminal carbon atoms, that means the one on the extreme left and the one on the extreme right will be bonded to by three hydrogen atoms each, and the two carbon atoms in the middle of the chain would each be bonded by two hydrogen atoms. So this gives us a grand total of C4 and H10 in the displayed formula of butane. And finally, looking at the skeletal formula for butane, it would be like this. Every point would represent a carbon atom, and all the remaining bonds that are not displayed here will be the ones that are present between carbon and hydrogen atoms. So these are the different types of formulae of butane. Next, we will be looking at the different types of formula of alkenes. So a four carbon alkene would be called either but1-ene or but2-ene. So taking but2-ene as an example. So the general formula of alkenes can be represented with a double bond between two carbon atoms. And in terms of the number of elements present, it will be CnH2n. And the molecular formula for but2-ene would be C4 and then 4 times 2 is 8, so C4H8. And its empirical formula in the simplest ratio of carbon and hydrogen would be CH2. Next, we have the condensed structural formula. So, but2-ene means the double bond would be present between the second and the third carbon atom. So, we'll start with a CH3 going on to a CH with a double bond next to another CH and finally a CH3 at the end. So, this is the condensed structural formula of but2-ene. Now, in order to display this structure, we would have four carbon atoms in a straight chain, a double bond between the second and third carbon atom, one hydrogen each on the two double bonded carbon atoms, and three hydrogen atoms on each of the remaining carbon atoms. So this gives us a displayed formula containing four carbon and eight hydrogen atoms. And finally, the skeletal formula of but2-ene would be like this, and a double bond present between the second and the third carbon atom. Next, we'll be looking at the types of formulae of alcohols. A four carbon alcohol can be butane, one all. So the general formula of alcohols is ROH, and in terms of the elements present, it will be CnH2n plus 1 and then the functional group OH. Next, we would have the molecular formula of butane 1-ol. So butane 1-ol will contain C4 and in total 10 hydrogen atoms and 1 oxygen atom. Now, since it has only a single oxygen atom present, this formula cannot be simplified any further. So the empirical formula, which is the simplest ratio of the elements in a compound, will be the same as the molecular formula of butane 1-ol, which is C4H10O. Next, looking at the condensed structural formula, we've got the all group or the alcohol group present on the first carbon atom. So we can have a CH3 next to a CH2 attached to another CH2 attached to another CH2 to which the OH group is attached. So this is the condensed structural formula of butane 1-ol. Now, in order to display this formula, we would make a carbon chain having 4 carbon atoms followed by an OH group. And on all the remaining positions on the carbon atoms, a hydrogen atom would be present with 3 hydrogen atoms present at the end and 2 hydrogen atoms present on carbon atoms in the middle of the chain. So this is the displayed structural formula of butane 1-ol. And finally, to make the skeletal formula, we have butane and then the OH group present at the terminal carbon atom. Next, we'll be looking at the types of formulae for halogenoalkanes. So a 4 carbon halogenoalkane can be 2-bromobutane. The general formula of halogenoalkanes can be written as Rx, where R stands for the alkyl group and X stands for a halogen atom. X here is halogen, and the halogen that we are using as an example is bromine. And the general formula for halogenoalkanes in terms of the elements present is CnH2n plus 1 and then X. The molecular formula of 2-bromobutane would be C4, then we would have 2n plus 1. So 4 2s are 8 plus 1 9. H9 and then X here stands for bromo, which is bromine, so Br. Now, since there is just a single bromine atom present in this compound, the empirical formula cannot be simplified from the molecular formula and will be the same. So the empirical formula of halogen would be C4H9Br. In order to see the condensed structural formula, we look at the name 2-bromobutane, which shows that bromine is on the second carbon atom. So we start with CH3, then we have CHBr. Because this is the second carbon atom and bromine is on this carbon atom, we can place bromine in a bracket. Then we have a CH2 and finally a CH3. So this completes the butane part of the name. Now, in order to display this formula, we have 4 carbon atoms placed in a straight chain with 2 hydrogen atoms present on this carbon atom, 3 hydrogen atoms present on the terminal carbon atoms, a single hydrogen atom placed on the remaining carbon atom, and the only bond left would be that between carbon and bromine, forming 2-bromobutane. The skeletal formula of 2-bromobutane would begin with drawing the skeletal formula of butane and then placing a bromine atom at the second position. Next, we'll be looking at the types of formula for carboxylic acids. So a 4 carbon carboxylic acid is called butanoic acid. So the general formula of carboxylic acids can be represented as RCOOH, and in terms of the elements present, it can be written as CnH2n plus 1 COOH. So 4 carbon carboxylic acid would have 1 carbon as the COOH group, so the remaining number of carbons would be 3. So C3 and H would be 3 to the 6 plus 1, 7. So in total, 3 carbon in the R group and 1 carbon in the functional group. So C4, 7 carbons in the R group and 7 hydrogen in the R group and 1 hydrogen in the carboxylic group. So H8 and 2 oxygen atoms in the carboxylic group. So O2. C4H8O2 is the molecular formula of butanoic acid. In order to simplify this, we can divide these numbers by 2 so that we end up with C2H4O as the empirical formula, which is the simplest ratio of the elements present in the compound. Next, the condensed structural formula. So we start with COOH as the first carbon atom. Then we have a CH2 group, another CH2 group, and a CH3 group in order to complete a carbon chain of 4 carbon atoms and completing the condensed structural formula of butanoic acid. Next, we will display this condensed structure by showing all the bonds. So we have 4 carbon atoms in a straight chain. Each carbon atom except for the functional group carbon atom will be bonded to by hydrogen atom in all the remaining positions, and the functional group carbon atom will have a double bond O and a single bond OH placed on it, completing the displayed formula of butanoic acid. And finally, the skeletal formula would be 4 carbon atoms with a double bond O and a single bond OH at one of the terminals, completing the skeletal formula of butanoic acid. Next, we'll be looking at the types of formulae of esters. So, a 4 carbon ester can be methyl propanoate. The general formula of esters is RCOO, and we write R or R dash. R dash would represent a different R group, and if we just write R, it could mean that the R group on both the sides of the C double bond O group is the same. And in terms of the general formula representing the number of carbon, hydrogen, and oxygen atoms, this would be CnH2n plus 1, C double bond O, CnH2n plus 1. So we've got a CnH2n plus 1 on both sides of the C double bond O group. Next, the molecular formula of methyl propanoate. So this would have 4 carbon atoms in total, which would mean it would have 8 hydrogen atoms in total and 2 oxygen atoms as part of the C double bond O group. And the simplest ratio of these elements, which would give us the empirical formula, would be C2H4O. Next, the condensed structural formula. So now we've got methyl as part of the alcohol end of the ester, which would be bonded to a COO. So this is it, CH3 methyl, and since it is propanoate, C double bond O carbon being the first carbon atom of the carboxylic acid portion of the ester would have a CH2 and then a CH3 group bonded to it. So this completes the condensed structural formula of methyl propanoate. Now, in order to display the structure, we would have 3 carbon atoms in a straight chain, followed by a double bond O, a single bond O, and a carbon atom attached to the single bond O. So this carbon atom would be a methyl group, so 3 hydrogen atoms attached to it. The terminal carbon atom on the other side would have 3 hydrogen atoms attached to it, and the carbon atom left in between would have 2 hydrogen atoms placed on it, completing the displayed structural formula. And finally, looking at the skeletal formula, so we would have 3 carbon atoms placed in this way. This carbon atom would have a double bond O and a single bond O group present, and a single bond showing it is attached to a methyl group. So this is the skeletal formula of methyl propanoate. Next, we'll be looking at the types of formulae of ethers. So a 4 carbon ether would be named ethoxy ethane, and the general formula of ethers would be R OR if both the R groups are the same, and RO R dash if both the R groups are different. And in terms of the elements present, this would be CnH2n plus 1 next to an oxygen atom next to another CnH2n plus 1. Now looking at the molecular formula of the ether, we have four carbon atoms. So this would be C4, then it would be H2n plus 1. 4 to the 8, and then plus 1 is 9. And if you count the hydrogen atoms on both sides, it would be H10 because ethoxyethane would mean CH3, CH2 on both sides of the oxygen atom. So C4H10 and an oxygen atom in between. Now, since the oxygen atom is a single oxygen atom, the empirical formula is equal to the molecular formula of ethers, and it would be Cn, or in fact C4, because we are looking at an example. So C4, H10 and O. This is the empirical formula of ethoxyethane. Now for the condensed structural formula, we would have a CH3 next to a CH2 group. In between the carbon chains would be an oxygen atom. Then another carbon chain would begin with a CH2 and ends with a CH3. Now in order to display this, we have two carbon atoms, an oxygen atom and again two carbon atoms placed in the straight chain, and hydrogen atoms bonded to each carbon atom at the positions where bonds are possible. So the terminal carbon atoms would have three hydrogen atoms placed on them, and the ones in between would have two hydrogen atoms placed on them, completing the displayed structural formula of ethoxyethane. And finally, the skeletal formula, we have two carbon atoms bonded to an oxygen, and then again we have two carbon atoms. So this is the skeletal formula of ethoxyethane. Next, we'll be looking at the types of formula of aldehydes. A four-carbon aldehyde is butanol, and the general formula of aldehydes would be R bonded to a CHO group. In terms of the elements present, it would be CnH2n plus 1, and then the functional group CHO. So, for a four-carbon aldehyde, it would be C4, then we would have H8, and then an oxygen atom. So C4, C4, 4 to the 8, yes, C4H8 and an oxygen atom. So this would mean that we cannot simplify this formula any further. So the empirical formula would be the same as the molecular formula, C4H8 and O. Now, in order to show the condensed structural formula, we've got the first carbon atom is the CHO group attached to a CH2 group attached to another CH2 group, and completing the chain would be a CH3 group at the other end. So this is the condensed structural formula of butanol. The displayed structure formula would have four carbon atoms placed in a straight chain with a double bond O and a single bond H present on the carbon atom that is part of the functional group. Three hydrogen atoms present at the terminal opposite to the functional group, and the middle two carbon atoms would have two hydrogen atoms each placed on them. So this completes the displayed structural formula of butanol. And finally, we have the skeletal formula in which we can have a structure like this bonded to a double bond O only, or we can have a structure like this bonded to a double bond O and a single bond H. Now, hydrogen is attached to the carbon atom that is the functional group. So, it is very much possible that the hydrogen atom may or may not be shown in the skeletal formula. So, both ways of making the skeletal formula are equally correct. Next, we'll be looking at the types of formula of ketones, and a four carbon ketone would be butane, 2 one. The general formula of ketone is R COR. Now the R groups can be same or different. If it's a different R group, we can place a dash on the R, showing that it's a different R group on both sides of the C double bond O group. And in terms of the elements, the formula would be CnH2n plus 1, CO, then again CnH2n plus 1. Now, since we've got four carbon atoms present in the ketone, butane 2-one, the molecular formula will be C4H8 and O. The empirical formula will also be C4H8O because we've got a single oxygen atom present. So the simplest ratio would be the ratio given in the molecular formula. In order to make the condensed structural formula, we have the C double bond O placed at the second position in the name. So we would have a CH3 group placed on one side, and in order to complete the four carbon chain, we would have a CH2 group followed by a CH3 group. So this is the condensed formula. In order to show the C double bond O group as a condensed group, because in the condensed formula we don't show the displayed form of the group C double bond O, we would write it as CO in between the CH3 and the CH2 groups. Now, to display this ketone, we would have the C double bond O group placed like this, showing the double bond, then a carbon atom with three hydrogen atoms attached to it on one end, a carbon atom with two hydrogen attached to it on the other end, and completing the chain, we would have a CH3 group placed at the terminal, completing the structure of butane 2-one. The skeletal formula of butane 2-one would be four carbon atoms made this way and a double bond O placed at the second position on the chain. Next, we'll be looking at the types of formula of amines. A four carbon amine would be butyl amine, or it could also be called amino butane. So the general formula for amines would be an R group attached to the functional group, which is NH2. And in terms of the carbon, hydrogen, and nitrogen atoms, this would be CnH2n plus 1 and an NH2 group placed next to it. So a four carbon amine would have C4, H11 and N present on it because the functional group has two hydrogen atoms attached to it, so the number of hydrogen atoms increases. And since the nitrogen atom is just a single nitrogen atom in the molecular formula, the empirical formula would be the same as the molecular formula, as one nitrogen atom cannot be simplified further. So C4H11N becomes the molecular formula as well as the empirical formula of aminobutane or butylamine. In order to draw the condensed structural formula, we would have four carbon atoms in a straight chain with hydrogen atoms attached to them. So that would be CH3, CH2, CH2, and another CH2. And then finally, we would have an NH2 group placed at the end in order to form the amine. Now to make the same formula in the displayed form, so four carbon atoms in a straight chain, then a nitrogen atom attached to two hydrogen atoms. And all the carbon atoms will complete their bondings with hydrogen atoms, with three hydrogen atoms at the terminal carbon atom and two hydrogen atoms on each carbon atom as part of the chain. The skeletal formula of butylamine would be like this, and then we would have an NH2 group placed on the terminal carbon atom, thus completing the skeletal formula of butylamine or aminobutane. Next, we'll be looking at the types of formula of nitriles. So, a four carbon nitrile would be called butane nitrile, and the general formula of nitriles would be R attached to a C triple bond N. This is the functional group of nitriles. So, in terms of the number of carbon, hydrogen, and nitrogen atoms, it would be CnH2n plus 1 attached to the functional group Cn. So now the molecular formula of a four carbon atom containing nitrile would be C4H7n. And since they're just a single nitrogen atom, this formula cannot be simplified further. So the empirical formula is the same as the molecular formula, which is C4H7N. Now, in order to draw the condensed structural formula, we will start with the C triple bond N group, which will be the first carbon atom, attached to a CH2 group, attached to another CH2 group, and then finally a CH3 group at the other end or at the other terminal of the chain. In order to display this, we have four carbon atoms in a straight chain with one carbon atom triple bonded to a nitrogen atom. At the other end, it would be a carbon atom attached to three hydrogen atoms, and the middle two carbon atoms would each be attached to two hydrogen atoms, thus completing the displayed structural formula of butane nitrile. And finally, we would have the skeletal formula, which would be like this, and then we would have the third, or rather the fourth carbon atom, in this case the first carbon atom triple bonded to a nitrogen atom. Or we could also have the structure drawn this way with C triple bond N made at the end, showing that it is a nitrile. Next, we'll be looking at the types of formulae of acyl chlorides, and a four carbon acyl chloride would be known as butanoyl chloride. The general formula of acyl chlorides would be R bonded to the functional group, which is COCl. And we would have, in terms of the carbon, hydrogen, oxygen, and chlorine atoms, the formula as CnH2n plus 1 COCl, which is the functional group. So in butynyl chloride, we would have four carbon atoms in the chain, and we would have seven hydrogen atoms present attached to the three carbon atoms, because one of them would be attached to an oxygen and a chlorine atom as part of the functional group. Now, since the molecular formula has a single oxygen and a single chlorine present, the empirical formula would be the same as the molecular formula, being C4H7O and Cl. This is the empirical formula of butanoyl chloride. The condensed structural formula would begin with the first carbon atom, which is part of the functional group, so COCl. This would be attached to a CH2, then again attached to a CH2, and finally attached to a CH3, thus completing the four carbon chain. In order to show the displayed formula, we would have four carbon atoms attached to each other in a straight chain, with one of the carbon atoms at the terminal attached to a double bonded O and a single bonded Cl. The other end would have a carbon atom attached to three hydrogen atoms, and the remaining two carbon atoms being attached to two hydrogen atoms each. Now, in order to complete the skeletal formula, we would make a structure like this. Then we would have a double bond O and a single bond Cl placed at the terminal carbon atom, completing the skeletal formula of butanoyl chloride.